Hi everyone and welcome to our next tutorial. In this tutorial we're going to take a look at what we call a parallel circuit. What a parallel circuit is, it's where we have a DC battery that supplies current in this direction through ammeter 1, and then when it gets to this point down here, some of the current will travel this direction down that branch, and some of the current will go down in this branch here. So if this battery is a 12-volt battery, what that means is when the battery looks out at the resistors connected to it, it sees this resistor here, we'll call it R1, in parallel with this resistor here, R2. The voltage drop across R1 in this example must be equal to R2. In other words, if this is positive 12 volts at this point, coming back into the battery here must be 0 volts. So what that means is the drop across this resistor here, R1, must be equal to 12 volts, and this drop across R2 must also be equal to 12 volts. So if ammeter 1 reads, for instance, 8 amps, if I know that R1 and R2 are equal in resistance, so if R1 is equal to R2, that means each one has the same amount of resistance, and 4 amps will end up running through this resistor, and 4 amps will run through this resistor here. So when the current comes through here at 4 amps and the current comes back up here at 4 amps, the current meets together, and what A4 will read is 8 amps. So 8 amps ends up leaving the circuit going through A1, 4 amps goes through this branch, and 4 amps goes through this branch here. This is an example of Kirchhoff's current law in a parallel circuit. In this case here, since the resistors are the same, the total current leaving the battery must equal the total current coming back into the battery. That's it for this example. Take care. We'll talk to you soon.